Hello everyone. So here we have problem number one. Uh, so basically we have insulated beaker with a negligible mass contains 0.225 kilogram of water at temperature of 76 degrees Celsius. How many kilogram of ice at temperature of minus 16 degrees Celsius must be dropped into water to make the final temperature of the system 37? So if we look at here, we know that the final temperature is 37, positive 37 degrees Celsius. So thus all the ice will be melted and will be converted into liquid. So we have to know how much kilogram of ice you should drop it at minus 16 degrees Celsius so that the final temperature becomes plus 37 degrees Celsius. Okay, so basically you have a formula where it says that Q hot plus Q cold is equal to 0, okay? Or you can say that Q hot is equal minus Q cold. Particularly in our case, we can say that heat lost by water is equal heat gained by the ice, okay? Now, first of all, we have to calculate how much heat will be released when ice is dropped into water, and the initial temperature of the water was 76 degree and the final temperature of the water was 37 degrees. So we have to know how much heat is released basically when it went from 76 degree to 37 degree, and that heat which was lost by water will be gained by ice in order to be melted, okay? So the equation for that one, first we have to calculate how much heat is released by the water. So we have equation where Q heat released by water is equal mass of the water, specific heat of the water, and change in temperature. So we know that water goes from 76 degree to 37 degree. So by plugging all these values, so basically we have mass of the water, specific heat of the water, and in general you can say that 37 minus 76. Why? Because this is the final one and this is your initial one, okay? And then you got minus 36,732. As you know that this is heat is unit is joule, so thus minus sign is just means that heat was lost by water, okay? So in general when you're calculating, just ignore this sign, okay, and keep it plus one. So basically you have to know when you have to put minus, when you have to put plus. But as I said, this minus sign means just how much heat was lost by water. Now, this heat will be given to ice so that it can melt it and it can bring to the final temperature from minus 16 to 37 degrees. Before solving regarding the things for the ice, we have to know a couple of things. So in general, you have such a graph, okay, where temperature versus heat. Now we know that our ice is below 0 degrees, so let's say it's around 16 degree. What happens if you start adding heat? It will keep increasing, and then temperature basically will keep increasing, okay? But at 0 degrees Celsius, what happens is that ice has to go to the phase change, where when you keep adding the heat, temperature will not increase, but however, this all ice will be converted into liquid at 0 degrees Celsius, okay? And then after that, it will go to the next stage, which is third one, and you keep adding heat, and then temperature of the water will start increasing, okay? So we are somewhere started from here, and then somewhere here is okay. That's so we can see that we had three stages, okay? One is increasing the temperature of the ice, then latent heat of fusion, and then again increasing when it become a water, okay? So now so basically let's look at this formula. First, ice is going from minus 16 degree in the first stage until 0 degree, okay? So that means mass of the ice, specific heat of the ice, change in temperature, okay? Then plus, and then it has to go through phase change, okay? where ice should become a liquid at 0 degrees Celsius. So you'd have mass of the ice, latent heat of the diffusion, and then once it fully changes the phase, when it becomes liquid, so it has to increase the temperature from 0 till 37 degrees, okay, which is this one. Then that means mass of the ice, specific heat of the water, and change in temperature. So that's it. So delta T will be basically so delta T is basically, so this one. So I just brought mass of the ice outside to the bracket. This is specific heat of the ice. Change in temperature will be from 0. This 0 is final, okay, and then minus 16, because it was started from minus 16. Then we have latent heat of fusion, which is this one. It's given in K, so you have to make it 334,000. Then specific heat of the water, and then final was 37, initial was 0, so 37 minus 0. So when you calculate it, you will get such a thing. So mass of the ice multiplied to this amount of number, and then this will be equal to the specific heat of the water, which was already the heat released by the water, okay. So equalize them. At the end, you just find what is the mass of the ice.